So, welcome to my presentation, Audit Assistant. Let me see. Okay. And also, so transforming audits with AI and empowering auditors through LLM and RAG. So first of all, before I explain the product, I want you to know like who auditors are and what are we using this LLM and RAG to help auditors with. So auditors basically are accountants that are very well versed in policy and regulation and help the company stay in line. So in their daily tasks, they have a lot of verification, comparing documents, looking to see everything's in check. And so it's a perfect case because they use a lot of text. So therefore, they can use LLM. But how can they use it? We'll get into that in slide 2. I'm focusing on one specific audit, and for the purpose of this project, it's called Proxy Audit. We're not going to use internal so I do this come up with solutions for audit team in my day job. I'm not using any I'm using public data, no internal sources. And so why did I choose Proxy Audit? One of the reasons is that also it's text-based. So what is proxy statement? So it's a statement that every publicly traded company puts out before the shareholders voting annual meeting, so they know what they're gonna vote on. So usually before they release the document, auditors go through every items of interest and check that those are true so that they're not liable for putting out false information. And they usually check it with source documents that are in Excel files, PDFs. For the purpose of this project, I've used the Tesla proxy for 2022 and 2023 document. But why use RAG? How is it helpful here? So basically, auditors have to go through this document and answer certain questions. And RAG is what we can use, and this document is usually in PDF, so RAG is perfect for answering those questions. But not only that, when we want to use the power of LLM to do tedious tasks that auditors do and like give it to LLM to do, we kind of want to have it do a Q&A, but it's if you ask an LLM, it gives you general answers. You want to kind of tune the LLM to have the context to answer those to answer those questions. And how you do it is you use RAG. And some of the benefits of using RAG for this is that you can retrieve data from public and also use proprietary sources. You can do Q&A with documents. You can provide verifiable answers. So because you document the steps that you do that, you can get the chat history and document that. And also it provides references. What chunk of document did it use to answer this question? So going to the next slide, for the purpose of this project, I've used proxy document. Instead of using a source document, I've used the proxy document for 2 years because I don't have the internal sources that they use to verify, but the two documents have similar information, so it's a good replacement for that. And as an LLM model, I've used GPT 3.5, and for embedding model, I've used text embedding 3 small. Let's look at the architecture. So basically, I've taken those PDFs and embedded them and saved them in a vector store. I'm using Face, and then it does when the user or auditor here through the prompt submits a question, it embeds that, looks for the relevant context, and then the LM generates the answer. And I'm using this using LangChain. So here's an example of Q&A from the app. I'm going to take you directly to app to show you something that came up, which made me do more stuff with it. So, for example, others are asking how many shares are available for future issuance under equity compensation plans of 2021 and 2022. It says the end of 2021 was not provided, but 2022 was provided. That's a false answer. So why does that happen? Because we've combined both texts, and this is something that happens when you have multiple sources or a lot of documents. If you ask it to bring back like top K, like top 10, top 3 sources, it might not capture the relevant information, and then it will say, well, we didn't have it, but we have it. So what is the solution for that? The solution for that, going back to the slides, is using a different architecture. And okay, for the purpose of this, you take each document and you store it in 2 different vector stores and retrievers, and then define a tool. And each retriever is a tool where you describe what is the each vector store storing. So when your query is asked, it knows what question to ask of which document, so it can give more relevant answers. And in order to do that, I've used Llama, and I'm going to show you how the answer looks, and we can also see it in the notebook if you wanted. So I'm asking the same question. How many shares were available for future issuance under equity compensation at the end of 21 and 22? And if you can see, it asked the 21 of the 22 proxy document and 22 of the 23 document, because I've told it what information is stored in which document in the description of the tool, which is the retriever. And it gives us the right answer, and it doesn't make the same mistake as using the combination of the documents. So, what is the success metrics? What did we achieve doing all this? First of all, the thing that the auditors do is go through all of these documents manually, make notes, store it in their brain where it is, and also have to make extra documentation for that. So what we're doing, we're saving resources and time, because we can, through the app, see we have the attached resources, so they don't have to make all of that, and they can directly go to and automatically document what they have. This way, it also decreases the error that humans can make, and also creates a trail of references. Recreating steps is really important at audit, so it also takes care of that. The other things that auditors can use LMs for are ideations, recreating steps, and populating the final report. And I do want to take this in the future. I want to take this to a further step, which is making it more agentic, and also partially automating it. In order to do that, the steps that we need to take is automating line parsing. So we're parsing lines from all the documents, especially the main proxy, and then through the tools that we have defined, LM is going to know where to cross-check that information. It's going to find a discrepancy and do an integrity check, and then at the end compile a report with all of the discrepancy that it's found. Of course, this is more complicated. I mean, as complicated probably as it sounds. And yeah, that's my presentation. If you have any questions.